Okay, in this video, I'm gonna show you the two strategies involved to solve this integral. The two strategies I'm gonna use is integration by parts and partial fraction. And the way how you can identify is when you take a derivative of the inverse tangent x here, you're gonna get 1 over 1 plus x squared, and then this part is gonna take the dv where it gets integrated. That way you will have du du, which is a fraction, multiplied with another fraction v. Well, instead of talking about it, I will actually show you by setting first u equals inverse tangent. Well, if I take a derivative of that, I get 1 over 1 plus x squared dx, and dv, I'm gonna take the other guy here. Okay, this is dv I'm setting, and this will be u. So dv equals 1 over x squared and dx, and if I set the integral, I get the v equals, well, that's same thing as x to the negative 2. So if you plus 1 here on the exponent, you get x to the negative 1 over negative 1. So therefore I get minus 1 over x. Okay, remember that the integration by parts requires you to multiply u times v minus the v times du. Therefore I'm gonna multiply now u times v, inverse tangent x times 1 over x plus, actually it's minus, my bad, minus this thing, 1 over x times the 1 over 1 plus x squared. Notice this is where we can use the partial fraction. So let me actually write the strategies. Let me share the strategies. Did I spell it right? Strategies, yes. Integration by parts, which I've just done, and then the partial fraction. Okay, so I can first multiply the negative in front. And instead of worrying about integral, let's first tackle the partial fraction. So I can write the 1 over x. Okay, let's save some space. Okay, 1 over x times 1 over 1 plus x squared equal, I'm gonna set this part to be a, so I have a over x, and then plus, I have to have a bx plus c because the highest term in the denominator in the second term here is x squared. Therefore, you just have to have the x in front of b plus c. So I have a 1 plus x squared. Had it been just 1 plus x, you would have just b. Therefore, I can multiply on both sides by x times 1 plus x squared and then makes the left side equal to 1 because they will simply cancel out. So on the left side I have 1, and on the right side the x will be cancelled out on the first, so I have a 1 plus x squared times a, plus I have x times bx plus c because 1 plus x squared get cancelled out. Okay, I can expand the terms by distribution. So I have a plus a times x squared plus bx squared plus cx. I see the like terms here, and I also see the like terms here. and Cx is all alone by himself. Let's actually use different shape. So we just know A equals 1, then Cx is gonna be 0, so C is simply 0. And then I have ax squared plus bx squared equals 0. I can divide both sides by x squared, so I have a plus b. So, but already knowing that a equals 1, I can simply set b equals -1. That way you will have 0. So b is -1. And that means I can replace a with 1. So this becomes 1, and c is simply 0, and this just becomes -x. Okay, this thing that we just found will go into here. So we'll replace that. So let me write the answer again. So inverse tangent x over x plus 1 over, since a equals 1, 1 over x plus 1, no not 1, -x over 1 plus x squared dx. I can split this into two integrals. And based on the definition of the 1 over x dx integral, you simply get ln x. So I'm gonna write that here. You get just ln x. However, on the second integration, just use a U-Substitution. So if I set the bottom, the 1 plus x squared, and take derivative of this, I get 2x dx. And divide both sides by 2, you get the x dx equal du over 2. That means I can simply substitute this over here, but remember that the negative is still retained. Just to prevent the mistake, I'm gonna have a minus in front, and then I have integral, and then du over 2 is gonna be replacing it, but I know that 1/2 can be pulled out, so I will write it in front of the integral. Du over u, and this again has the same format as the 1 over x dx integral. Therefore, I'm gonna have -1/2 ln u. Okay, I can put u here with the absolute value. However, notice that 1 plus x squared will be always positive. Therefore, the absolute value is not really needed. So instead, I'm going to have a parenthesis, 1 plus x squared plus c. However, some teachers really want you to condense the formula using the log properties. Therefore, which I'm going to show you step by step. So first step is you pull the coefficient to be you pull that to the function, the ln function, and then make sure that becomes the exponent. However, also make sure that it's not, the ln itself is being 1/2 to the 1/2. So I'm gonna put the bracket outside. So this exponent is in between the parentheses and the bracket. So that's just step 1. And after that, I'm gonna combine them, the log properties of addition. So that means that I can simply multiply the function Oh, actually, it will be, I'm sorry, it should be the subtraction difference. So you see the minus sign, so this function will be on the bottom, and then that will be on the top as a ratio. So but first, let me clean this up. So I have ln. I'm gonna put the radical sign here, 1 plus x squared, and then plus c. You could put the parentheses with to the 1/2, but I like to keep the radical for power of 1/2. Alright, so I like to combine this. To do that ln x is gonna be on the top, but since I have minus, this function that follows will be on the bottom. Had it been the plus sign, then you simply multiply them out. Because x can be both plus and negative, I must have absolute values to get the full credit, and I have the final answer.